Okay, normally it should be this or this, right? Okay, so this is, I'm going to try to explain you all the concepts to build the DI component and what it provides. It's a workshop, so I'm going to try to give you the opportunity to do something with code. I'm going to do code myself, and I want to encourage you to do the same, basically the same as I do. So if I'm going too fast, just tell it. Also, it's a workshop, it's not a conference, so it must be interactive. Okay? So please do ask questions. Please make it very interactive. I can do it alone, but you will not learn as much as if we think together by having some interaction. Okay, so let's go. So I have some slides. They are from 2017, because Symfony 4 is like since 17. And of course, we improved the component the last years. And so we'll also review, and I will tell you when we improve things. Okay? So Symfony forever. I like that one. So first, as a short reminder, Symfony 5 is going to be released at the end of November this year. Symfony 5 is going to be released at the same exact time as Symfony 4.4. Symfony 4.4 is going to be the next long-term support version of Symfony, right? And Symfony 5 will have no new features. All new features will be released in Symfony 4.4, right? Symfony 5 is just about removing all the deprecated code path. So it's just a cleanup of 4.4. So the marketing will focus on Symfony 5. The technology is 4.4, right? We will require PHP 7.2 in Symfony 5. That's the only thing you need to know. I mean, you cannot migrate to Symfony 5 if your infrastructure did not migrate to 7.2 yet. And that's it. About the major version moves, this is the same slide I always show, because now it's the second time. Yes, it's the second time we bump the major version, the third time. So now we have a process. We have a process in Symfony to move from major to major. And the process is to flag all the deprecated code usage with deprecation notices in the latest version. So Symfony 4.4, if you move your application to Symfony 4.4, you will see maybe deprecation notices. And the idea is that if you clean them all, then you're ready to move to Symfony 5, right? So we want it, and we spend a significant amount of time in the community to ensure this works. Basically, that you can move from 4 to 5 easily. Easily is like, okay, it's still some work, of course. Okay, so Symfony 4, maybe you know it, maybe you feel it already. So the idea of Symfony 4 is to automate as much configuration as possible so that you don't have anything to do, like nothing to configure if you are just using some common way of wiring services. And then, of course, at some point, because each application is different, you might need, and you need to know, how you can express your own set of convention or exceptions to the conventions. And this is basically when we need to do dependency injection configuration. And then now I have only slides like that. Dependency injection, I don't know. So quick reminder about dependency injection. If it's not clear again, ask question. This is a pretty core concept in Symfony, so you need to understand it. And if you don't, it's okay. Just ask. Okay? So dependency injection is about never creating an object, a service object inside a class of your own code, right? So you never, when doing dependency injection is like never doing a new something in your code. New or some alternative like static factory, foo : create something. If you do that, it's not dependency injection. And dependency injection, on the contrary, is about asking for the from the outside world to provide you with the service, the dependency you need through a constructor argument, typically. It's okay for everyone about that? So we'll see with the code. Let's create something, right? So we are going to create a small Symfony skeleton application and to create some services there and to figure out several ways to wire things together. Okay? And then I'm going to explain that because I think it's always useful. So there are two ways to create a Symfony application nowadays. One is this one. So I already have installed the Symfony binary. So I do have a Symfony command line. I don't know if you have it. Who already has it? It's installed. Oh, great. So you can run Symfony new and some directory, right? There is another way to achieve the same, which is using Composer. So create project, and then it's like Symfony skeleton, and this will do the same, just using standard Composer with more output, but basically that's exactly the same. Okay? So removing the second one because it's the same. So here we have a very simple Symfony application, right? There's nothing there. I'm going directly to add some tools we're going to need. So let's do it this way. Composer require. I don't know if you already have the maker bundle. We need the debug pack too. What else? The profiler. Maybe the debug pack already embeds that. Okay, let's start this way. I'm just building the Symfony application. Okay. So you know about Flex. You've heard about Flex. So Flex is creating like new configuration files automatically from some recipes that are available on GitHub, so that when we install any new package, it could be automatically configured, which is what is happening here. Okay, and okay, we can already start this Symfony serve. So I'm going to keep that console open to open a new one. So this one is running, and it's using the Symfony binary to run PHP FPEM behind an HTTPS reverse proxy, or proxy, basically. So this way. So what next? I'm going to create a controller because it's pretty easy. So I'm requiring annotations because annotation is a requirement for the routing system, right? So that I can create routes to a controller and maybe twig if we want to. I think we already have twig, but anyway. Okay. Next step. So I just created a controller, and so now we can open it. We can go there, and we have some welcome page, and we have some code to generate that, and we can hack that and do anything we want there. Do you have any question at this stage? Is everything completely obvious? Or do you have any question? I mean, it's the day. If you have any question, like things you were wondering, you don't need to drink my words, right? You don't have that? Did you run? And that wasn't the other one. I run that previously, maybe you missed that one. So right now I'm using the skeleton, and the skeleton doesn't have the maker bundle. So if you start with the website skeleton, then you have the maker bundle and much more things. So I like using the skeleton because we build things, and I think it's important during a workshop to start from scratch so that you maybe better understand the steps to go there. So a lot already happened behind the scene. Like, we just type some comments and we have a page. Yet there are many, many things that made that work. If you have no question, I'm going to continue because we are not yet at dependency injection. It's okay? Can I continue? Or does anyone need some more time? Okay. If you look at, git status will show me what happened there. So I'm going to add that just to have some snapshot of the state we have now, right? So we have the configuration for our packages, some routes, base templates, and that's it. So, in case you never checked that, I'm going to open it a few times today, this morning. We have, so if I list there, that's the layout, you know about it. There is the var folder, which is like the black box of Symfony. Let's have a look there. I want to show you that. So cache logs, if you don't know, you know. Maybe, okay, so this is a place to debug a Symfony application, of course. So if you want to have a look at logs, you can just open that one. But now I'm going to have a look there. So var cache, there is a subdirectory dev, which is the name of the Symfony environment. So by default, we run in the dev environment. And of course, in prod, it would be var cache prod, and so on. So, and there inside this one, there are a few files. What are those files? We have some container with a random name. I'm going to open that. We have pools. These are cache pools. There is a cache. There are cache layer, cache pools available by default, and that Symfony uses and that you can use too. They are stored there. There is the profiler where the toolbar stores the state that is displayed in the web debug toolbar. There is the two log files. So those log files are for storing deprecations and compiler logs for so that you know what happened during the compilation of the container, right? So Symfony is a compiled application. A Symfony application is compiled. It's PHP, it's not compiled, we are not Java, but actually in PHP, a PHP application is compiled, right? And compiled means that all these YAML files that are in the config directory and all the XML or YAML files or PHP files that define configuration for bundles in the vendor directory, all those files, they are parsed at some point at the beginning, at the first execution of the Symfony application, and they are all compiled into this folder, right? So then they are not read anymore, okay? And so the compiler log, I'm going to show you just so that maybe you never open that. Maybe it's just like don't touch, don't have a look for you. Yet it's not that complex. So let's open it a few minutes. So this one is like things and steps that happened during the compilation of the container. So random thing, removed, service, reverse container, reason, unused. And this happens to many services. This one, changed reference of services resetter previously pointing to debug.eventDispatcher to eventDispatcher. So basically, there are things that are called compiler passes, and a compiler pass is some logic that does that is part of the compilation steps of the container. So there is a definition of like configuration, then there is a compiler pass which does some transformation. There is a compiler pass, the previous one, which is looking for unused services, like unused services, and that decides when those services can be just removed from the container, right? So there are a lot of different compiler passes, and they all do one thing. And so this one is like replace alias by actual definition pass. So in the container, we have service aliases. Like a service can be named foo, and you can give it a second name, bar. And bar, you define it as an alias from foo. So that now to reference the service, you can have two names, bar or foo, right? And this is useful when you need to reference services sometimes. But when the compilation happens, we don't want to keep the alias because we don't want at runtime to have some, jumping in the discovery of the services. So we have a step, a compilation step that replaces all the aliases by direct links or pointers to the services. It's okay? If I'm going too fast, maybe I'm going too fast, or maybe it's just obvious, I don't know. Tell me. So, I don't read that much, okay? But sometimes, at least it's cool to know that it exists and it's not opaque. You can discover that. So, back to this. So the list is up. So next files. So this one is about deprecation, but I think we don't have any. It should be empty. The next one on top. So next one is this one. So this one is the actual entry point to create the container object. So the container, I'm using this word. The container is a concept, but at some point the container is an object. And an object has a class to define its behavior, right? And the class of the container is the result of the compilation, right? So the Symfony dependency injection component generates a class, and this class is PHP code, and this PHP code defines how services should be created. Okay, quickly. There is the same one in XML. So this file, the XML one, is the container dumped in XML. Why is this useful? Anyone has an idea? For PHP Storm, absolutely. So you know the Symfony plugin for PHP Storm? So the Symfony plugin looks at this file so that it knows about the container. Useful. Twig, Twig, it's like Twig files compiled to PHP, but this is not exactly the topic. The URL generator and URL matcher, those are the routing components compiled to PHP. So all the routes are dumped into some PHP class and they are there. The .meta files, you see several .meta files. Those are what we call resource files, and they allow invalidating the container whenever a file changes. So that's thanks to these files, we know which file we should monitor, so that whenever any of those files changes, then we need to invalidate the container and to compile it again now. right? This way, you don't have to think about clearing the cache. Symfony does it for you most of the time. Sometimes you have to run bin console cache clear, right? Or rm var cache -rf, right? You know this. So sometimes you need to do that, but most of the time you just change the code, refresh the page, and Symfony figures out that it needs to recompile the container on its own, thanks to those files, and done. Up, wrong folder. So this is the container. As you can see, it's just a pointer to another file. And this is where we include. So in this case, we know that it's this folder that is useful. So I'm going to use it. And so this class is the compiled container, right? So what does it contain? It contains a map, several maps. But basically, you'll find there all or most of the services defined in a Symfony application. So maybe, yeah. Okay, let's take this one. Maybe it's easier to read. So this one is called get twig service. So it's a method. When you call it, it returns a twig instance. So when you use twig, this is how twig, the object, is constructed. So what we do is that we create first a native file system loader. Okay, I'm discovering that with you, right? So then we add several paths to the file system loader. So those are apparently all the paths where twig files could be located. And so as you can see, each bundle is referenced there. So, and the last path is the templates path from the application. So now we know how twig is configured. Then we have the twig service itself. So this one is creating a new twig environment, which is the first class of twig you need to create. We configure it with some options, and then we have this object which is stored in a property. So that now, next time we won't call the method again, we just use the twig object that has been stored in this services array. Right? So, all this is code you could have written yourself. So basically, the Symfony dependency injection container is about writing code automatically when you could have written it by hand, but it's just more flexible to delegate writing this code to the component. Right? So there is, in the end, it's just straight PHP code. There is some logic before to turn the configuration into PHP, but in the end, this is PHP code. Okay, that was just the introduction. There are a few more files there. That's because the container is dumped in one class, the one we just opened, but for some services, we decide to split them in separate files. So twig is dumped as a method in the class. We just saw that. The reason is that twig is considered as an always needed service. So because it is always needed, then we inline it, basically. But for all the other services that are not used all the time, for all requests, we dump them in a separate file so that we don't have to load the code when it's not actually needed, right? So if I open any of those, let's do it, I don't know, this one, the maker generator service. I think you can understand this one is not used all the time. So this one is a pretty simple object we just create an instance of a generator class in the maker bundle. We give it another service as argument, the namespace, and done. Right? Yes?
Is the list of inline services hardwired or can it be configured?
So the list of services that are dumped there is a tag that controls that. So the tag is called container.hotpath. So if you tag a service with container.hotpath, then it will be inline. And if not, so this propagates to dependencies of dependencies. So if you tag twig, all the dependencies of twig will get the tag 2 at some point in the compilation step.
And the stuff that depends on twig?
They will not get it. Yeah. It works also for events. So there are some events that we flag. I don't remember exactly how, but there are some events. If you create a listener and this listener is bound to kernel.request, there is some logic. I don't remember exactly which one, but which will turn those as hotpath, as part of hotpath, right? So there's also this. So it's not ready yet. You know about PHP 7.4, right? Which is going to be released at the same time as Symfony 5. It's just a coincidence. So PHP 7.4 will have a feature which is called preloading. Have you heard about that? Yeah? So what is it?
Preloads assets.
Yeah. So preloading is about loading classes in shared memory so that on the next request, they are already loaded. We won't call the autoloader again, right? So it's a pretty significant performance improvement that doesn't work yet. Because I've tried to run it on Symfony and it seg faults or it crashes for some reason.
Did you preload all of the Symfony or just some components?
So that's the question then. Because preloading means that at some point you need to tell PHP which classes, which files you want PHP to preload. So which files? One option is all files in the vendor directory and the source directory. That's one option, right? It doesn't work because there are classes there that should not be loaded because they are like tests or missing dependencies, or it's not performant. I mean, Dimitri, the guy that worked on this feature, he shows that if you load too many classes, it's slow again. So you need to very specifically load only the classes that should be loaded, should be preloaded, and not too much of them, too many of them. Okay? So how do you decide which classes you need to preload? You can preload. And so there are some people that, there is an experiment, there are people that consider the classes that are found in the OP cache pool at runtime. So they say, okay, let's run the application. Now the application has run for 1 hour, so I can ask OP cache, which file do you have in your shared memory cache? And then you take that list, and you generate a preloading list for PHP so that the next time when you reboot the application, it will load the list and done, right? So that's one way that people play with that feature. In my opinion, it's not perfect because it needs this DevOps step, like, okay, we are in production, we are monitoring the list of files in the OP cache, we need to, okay, all this is like management, deployment strategies, and so on, so it's complex. So I'm trying another approach, which is based on exactly this feature, which is the hot path. So now we are going to say, okay, if a service has the tag container.hotpath, then all the files related to that service are candidates for preloading. So it's my code is ready. The PHP side is not because it crashes yet. But that's okay. We have still a few months to figure out. So I think the way this could work is that there will be a new file. That's my current. So we are talking about things that are not ready yet. So it's a pull request. So in this var dev folder, right now my current strategy is to generate a new file, which I would call like src app, etc. .preload.php. And then you will say to PHP, this is the file you need to preload. And this file will then in cascade preload all.
You can do the preloading on runtime, or do you have to configure PHP?
So you need to configure PHP. It's a PHP ini setting, and you give it one file.
But can you do it in runtime? Can you do init or?
No, you cannot. So you configure your FPM pool with that. So since the name is going to be stable, if you deploy a Symfony application, you should be able to say, okay, this is the preloading file you need to use because Symfony is generating it for me. So load that and done. And then we'll figure out all the logic to put the list there.
How should that work if you're deploying a new version of your app and just switch? You deploy a new version and switch the current symlink from the old one to the new one?
You need to reboot the server.
Yeah. Okay.
Okay? So, exercise, very simple. I mean, for some of you, I'm sure, maybe not for everyone, that's okay. Let's create a very simple service class in our application. Let's call it a greeter, and it's going to say hello, right? And let's use it in the controller we just created, okay? So the job is to say, instead of hello, which is a hard-coded string, let's create a service that will generate this string and use it on this page. You can do that? Okay, let's do it. You don't need me to do that. Or maybe you do, but I can. So, of course, so let's create a class, right, with one method. Let's call it greet. Or get greeting, something like that. And then this class, we are going to use it inside our controller to display that in the end. Okay? So that's the job. I'll let you do it. There are several ways to achieve that. And we are going to discuss them all. So maybe you have this kind of code already for the greeter class. I didn't tell you about the name argument, so maybe you don't have it, but basically it's just a very, very simple class. So any comments on that? Not yet? Okay, so this has one responsibility, which is like greeting a name. And so now we are going to use it this way. So I'm going to create a new variable in the Twig context, greeting, and I'm going to call the method to greet, maybe not the controller, but the summer camp, right? So let's open, I'm going to just use it there. So, and use it in Twig. And in the title. Okay, so now options. How do we create this greeter variable? So it's okay right now. I didn't do anything fancy. Okay. So what options do we have to create the greeter? I'm asking about this line. So how do we get an instance of this class? How do we do that? Which kind of options do we have? There are many of them, so raise your hand. Yeah? We inject it with a constructor. Okay, so we create a property, and then we type in with the greeter thing, and it works basically. Did you do that already? Yeah? So I know you know about this one, right? Okay, so let's make it work. Oops, sorry. So I'm not using like PHP Storm. Greeter. Okay, it works. So how did it work? AutoWiring. Okay. So, any comment about that? What could we say? Okay, second option. That's another proposal, I agree. Another way to get the greeter service is to inject it through the action. Okay? So what you can do here and what you can do now, I don't know, do you need some more time for someone? It's okay, I'm going too fast or too... It's okay? Continue? So the other option, another option, because that's not the only one, is to ask the greeter there, and then we don't need that anymore. And we don't need the constructor, but it's okay if it's here still. So this still works, so except that now we are getting the service through the action. Okay? Did you know about that? So it works only for controllers, because controllers are a very specific layer in the application. There is some hooking point in Symfony that allows taking full control of the arguments that are going to be provided to them, to actions. And so out of the box, we provide injecting services as arguments. Yes? Does it work with the invoke method? Yes, it does. Yes, it does. But only for controllers again. You mean like that?
Yeah, of course.
It works. Yep. So when would you use one style or the other?
Single action.
single action controllers. In this situation, what would you prefer? Which style would you prefer? Yes, but we have constructor or
Constructor rather.
you'd rather use constructor? Okay.
For the services and arguments to invoke method I would use for
Root?
or a root parameter.
Yes.
Or the thing that comes from sends the extra bundle.
Yes, the entities, the param converter. Okay, so of course, there are not only services that you can ask there. So one other, which is not a service, is the request. So if you type in for the request, you will get the request, thanks to the same mechanism, which will provide you not a service, but the request. And if you don't know it, you can also ask for a parameter here. And if you do that, you can get the name too. Here. So this won't work for, okay, but it can be made to work pretty quickly if you want that to work, right? I mean, it could work actually. We just. Mm-hmm. The request is not type hinted, so I can remove it or add a use statement. But basically, yes, it works. We don't use yet the name, but we could put it here. Works. So this is not dependency injection, but just in case, if you find that useful, you can do inline roots parameter configuration. So here I'm defining a parameter, right? And then we can make it optional this way. And then we can also define a default value. So I just did. Okay. And you can also define a constraint. You know about root requirements. So you can define that here. So if I want only numbers, this is it. Oops, sorry. So this works, but this doesn't. Okay? So that's not the topic exactly, but still it works. And it can be useful. So, just to make the link, and very quickly, with so this is the class. To create this class, how would you? You would just do new greeter. So another way to create the greeter object here is a way that is not dependency injection, which is this one, right? So don't do this, because if you do that, then you cannot test this controller anymore, or you cannot test the service anymore, or you cannot provide a different implementation of the greeter anymore, right? So don't do that, but basically this is the code you'll find in, I'm going, so var cache dev, we have the container somewhere, get, so I'm just linking things. So we open compiled files. So this is the file that is generated for the greeter service. So as you can see, this is exactly the code you would have written by hand. So how do you create a greeter service? You call new app greeter, done. And then we store that in the property to share the service, and so that if you ask it twice, you get the same instance twice. So the container is a registry of factories, this is one of them, and a registry of singletons, right? Of instances. Okay. Sorry, I'm switching. Yes, this is what I'm looking for. So things to say about this. Constructor injection versus action injection. It's up to you most of the time. Maybe you'll prefer one style or another. I don't have any specific things to tell you about that. There is not many difference between the two styles. There is one little technical difference related to laziness. If you have several actions in one single file, so index, but maybe other method in this, and if a service is needed only in one of them, then having the service listed as an argument on the action will mean that the service will be created only for this action and not for the other ones, right? Whereas if you define the service as a constructor argument, it's going to be needed all the time, so it's going to need to be created all the time. So there is a performance overhead in theory there. Make sense? Yes? So did you see my change? So I just did that, right? So what do we have now? We had it before, but now it's obvious. No? So final means we cannot extend the class anymore. Which means what? So if in your company you see a code like that, is it okay? Or are you going to say, you can do better? So this is one class, and this is the way we use it. Do you see any issue there? Oh, it's fine. There is an issue, of course. Which one? Any idea? Why do we do dependency injection? To be able to provide any kind of instance of the dependency, and so that this specific code doesn't care about which exact instance is provided, but could accept any, right? Is it the case for this? You cannot provide it anything else than a greeter instance. So if you want to create a mock of a greeter, you cannot, because a mock works by inheritance. You just cannot provide a different implementation to this class. So there is very little difference between this code and this code. There is almost no difference. The only difference is that maybe the greeter has some constructor argument and maybe you can configure it differently. Actually, there are not. So this class is tightly bound to the greeter implementation, right? So this is a design issue, right? So it's okay. How do we solve that? We can create a greeter interface, and that's the way to solve it. Yeah? So dependency injection, actually, we are doing dependency injection here. This is dependency, the greeter injection, because injection is like providing via an argument, right? So we are using dependency injection. I'm sure you've heard about the solid principles, like single responsibility, open closed, Liskov, inversion of control, and I don't remember. So dependency injection, dependency inversion or inversion of control. So dependency inversion is different from dependency injection. Have you thought about that? Did you think about that? So dependency injection, we're doing it. I think you got it. Dependency inversion is doing that, plus one more thing, which is coding against abstractions, which means accepting abstract dependencies, right? In PHP, an abstract dependency is an interface most of the time. So here we are doing dependency injection, but we are missing the upper level, which is dependency inversion, because we are coding against, which means in PHP type hinting for, a class. A class is an implementation. And an interface is an abstraction. So if we change greeter for greeter interface, we are going to do dependency inversion. And now we will be in the world of design, software design, right? Like decoupling, because the goal here is not to do it for fun, right? The goal is to accept change. The goal is to be ready for the next implementation of a greeter that this class shouldn't care about, because this class should care about an abstract greeter. It should know only that it has one responsibility, which is greet something, and that's it. How it works? We don't care, right? So how do we say we don't care? This way. Yes? So I'm going to remove that just because we don't need two ways of doing that. So let's do it. So I'm missing a use statement. Okay. Where is name null? Okay, cool. Any question? So, before we use the word AutoWiring, right? So we are going to talk a bit about AutoWiring. So what is AutoWiring?
Automatically provides dependencies.
Yes. So AutoWiring is like when the container needs to create a controller class, it's going to say, oh, I'm going to need a greeter. How do I get one? By AutoWiring. Okay. So how does it work? Okay.
By searching instances of the interface.
Okay, that's one proposition. By searching instances of the interface.
And if there's only one, it automatically injects it.
And if there is only one, then it automatically injects it. Make sense for everyone? So at some point, the container is about a list of services, right? So you know about the command which is called debug container. If you don't, now you know. So, okay. If you can read it, it's okay. So we have like names, twig, and then there is a definition for twig, and basically the container has a list of services, right? So now the container needs a greeter interface, and it needs to cherry pick one of the services defined there to inject it into the controller, right? That's AutoWiring. There are several missing steps before, right? I mean, right now it's like, is it magic? Yes? No, it's not magic? Ah, I thought I was a wizard. So, how does it work? Again, so it's like the 5 why, you know? Why does it work? Why and why? It works because of that. So, this is a file that is in your application. You can open it, config services.yaml. This file could be empty, and this file was empty in Symfony 2 and Symfony 3. The layout was a bit different, but basically the service YAML file was just empty. An empty service YAML file means do it by hand, right? So we can empty this file and we can make the application work, right? Which means if we do that, we do service configuration by hand. Do you want us to do that? Or would you know how to do it?
How to create a service by hand?
Yeah? In YAML, it's easy. Yeah? So let's do it. Yes? Okay, 10 minutes, not more. You open, so maybe you have this state. I hope, I missed that. So, you might have this working, right? So now, this is the job. Okay, let's make it work. Again, without checking out from Git. Okay, so just before the break, I'm going to give you the solution because we have one who completed the exercise, and you might have spent some minutes thinking about that. So the error message gives the entry point. So the routing system knows about the controller. The routing system says this route points to this controller, the one there. Okay, then it says, okay, I'd like to create an instance of this controller, but it has an argument. So the routing system cannot create this thing. Did you forget to define such a service? Yes, we never define such a service. So we are going to define it, actually. So let's define it. Up. Okay, so I just defined it. This is defining a service whose class is the same as its name, right? And that's it. It doesn't work yet, but the error will change. So I'm going to save that and refresh. And now it says, okay, there is no extension able to load the configuration. What's that? Oh, because I'm missing the services entry. So it's under services. Okay, so now it says controller cannot be fetched from the container because it is private, something new. Did you forget to tag the service with controller.service arguments? Yes, we forgot because we didn't know we had to. So let's do that. Okay. Next step. Yes.
So the controller service doesn't need to be public if you use this tag.
Absolutely. So this tag turns the service public and register the argument resolver that provides the argument injection.
Okay, so it's basically the same thing. Even so, defining the service as public or using the tag.
Yes.
It boils down to the same.
Yeah. So another way to make it work is to say public true, and this will still work. It will disable one feature, which is argument injection.
So if you don't use argument resolving, if you just use public true.
Absolutely. So I'm going to still follow the message, right? So now the error is different. Now it says too few arguments to the constructor, 0 passed, 1 expected. Yes, it needs a greeter interface, right? So it needs a greeter. So arguments. I'm going to provide it the greeter service, which is not defined yet. So okay, so now we are, last line is like, let's define a service which is named appGreeter, and that's it. The class of the service will be defined by the identifier of the service, right? This is the same as saying that. It's just a shortcut. Okay? So this is exactly so this defines a service whose class is exactly the same as its name. So back to this. String given. Because I'm missing a reference. Okay, it works. Right? Okay. So back to this. Okay, it works. That's where we were, which is nice. So now I'm going to reintroduce you with the previous default configuration and to explain you the steps to do that, right? So right now we are using explicit configuration. Here, so when we do service configuration, we need to give each service a name, right? So giving each service a name, the name is like you decide what the name is. So this one could be greeter, and I could define this like that. Okay? This should work too. Okay, so then we have this idea that, okay, finding a name is difficult enough for a class, let's reuse that name when it works, right? Which is the case here. So I'm going to remove them. Okay, no, maybe not remove. So let's automate the configuration. So everything is plain explicit right now, right? It works in Symfony 2. This works in Symfony 2. Maybe not because of the class missing, but anyway. So now I'm going to do, okay, AutoWiring. So let's remove this line. So this line is about explicitly defining the argument of this class, right? So AutoWiring should be able to do that for us, right? Let's do it. This means do your job. I don't want to be explicit. Let Symfony and the AutoWiring logic do the job. Will it work? Should it work? Do you think so? Yes, it should work? Okay. Does anyone think it should not work? Okay, why? Yes. Okay. you think that there is a name mismatch between the type hint and the service name. Yes, you're right. It doesn't work, which contradicts your previous statement. You remember before you said, oh, AutoWiring works by looking at all defined services and looking for one that implements greeter interface. There is one. It's the greeter, right? But still, it doesn't work. It says, cannot AutoWire service WebSC controller argument greeter of method construct reference app greeter interface, but no such service exists. You should maybe alias this interface to the existing greeter service. Everything is written there, right? So it's looking for a service whose name is the name of the interface, and that's it. No, because of expectations. If you were to define two classes that would implement this interface, then suddenly, and if a bundle does that, same. So the logic was this one in Symfony 2.8. In 2.8, we introduced AutoWiring as an experimental feature, but nobody used it because it was dangerous. Wow. And dangerous meant that. It was because it's like global state leak, right? So now there is one single global state, which is the name of the services. And when we try to auto-wire some type hint, we look for the exact name in the container, which means we don't care about the type. And the container doesn't care about the type. When you wire services by hand, you do @greeter. We could have written @logger, and the compiler would have happily compiled the code. Of course, later on, you would have had this error saying, hey, you're providing me a logger, but I need a greeter. But that's PHP, that's not the container. So, what does it say? Maybe you should alias this interface to the existing greeter service. So yes. App greeter interface is an alias for the greeter service. Okay, we are leveraging AutoWiring now. So that's AutoWiring. Okay, we defined it for one specific service. Of course, let's use it for all services by default. So that's why I'm going to move this line up in this up section, right? So now we are just moving one step upper in the abstraction level, and we say, okay, for all services defined in this file, and only in this file, so the controller, the greeter, and the alias, it doesn't make sense, but the greeter and the controller, they are both auto-wired, and only one of them will actually benefit from it. It's the controller, right? So AutoWiring is about filling the holes. Like there are some definitions. Some parts of the definitions are missing, like the arguments for the controller. But when AutoWiring can figure out by itself using this very simple logic, I told you about like the name of the service matches the type hint, done. You don't have to do it by hand. The configuration, the compiler will do it for you. That's AutoWiring, okay? So next step, let's remove the tag. So I'm going to do that again. So this breaks. That's the same error we had before because the controller is private. And actually because it's missing the tag. So we can ask Symfony to add the tag by itself. That is called auto configuration. So auto configure true. Without typo, it's better. So we just said to Symfony, add tags to this class on your own. How does it work? How does it work?
So it depends which class is our controller extending. Developer is going to figure out by
Yes, the way it works is that by having this enabled, we say to Symfony, look at the parent classes of the WebSC controller, parent classes and interfaces, right? So look at all the types that this class implements. And if there is a rule for one of them, apply the rule. And actually there is a rule. There is a rule which is defined by the framework bundle. The framework bundle has a rule somewhere that says, if a class extends abstract controller, and if this class is auto-configured, then add the tag. So this matches this class, so the tag is added for us, right? So I can show you, I'm going to show you the code in the vendor directory so you can see how it looks like. So Symfony, framework bundle, dependency injection, framework extension, and the method is named register for auto configuration. Okay, and this is the rule. It's okay. So now we are inside a bundle. A bundle, you can write bundles on your own, right? So this is the framework bundle, which is the first bundle that we all use in Symfony apps. So the framework bundle has several rules, common rules. This one is saying, container register for auto configuration the abstract controller class and define this rule at the tag controller.service arguments, right? This line is defining the rule for auto configuration. So if you are a bundle author, like in your company or in open source, you can define your own rules using register for auto configuration. Okay? Many bundles do that already. It's very useful to add automatic tags. So another example of automatic tagging, it's like a command. You create a command in the source command directory. You extend the command class from Symfony, and then it works. It works bin console my command, and it runs. How does that work? It works because your command extends command, and there is a rule, the first one, which says whenever a class extends command, add the console.command tag. And then the tag will be used by the compilation to identify all the classes that should be registered in the console application as a command. This is auto configuration. Okay? Any question about that? So, again, I'm going to move that up. So now, same, it works. And now all services defined in this file are going to be auto-configured. And so next step is about removing those lines and still make it work. How do we do that? So these classes, these lines are defining services. So we need a rule to say, define those services for me. Right? How do you do that? So you do that with a new rule, with another way, which is called, we call auto discovery this time. So we are going to ask Symfony to discover by itself the services. So auto discovery works like that. You give it a namespace, and then you give it a path relative to this file. So this file is in the config folder. So we need to go back and inside source, right? And so this rule says, look for all classes in this folder in this namespace and load them as a service. So it means, and loading as a service means giving them a name. Which name? The name of the class. obvious. So this one is already defined. This one is not defined because of the name. Here we have a different name. But actually defining like it was before is okay. So now we can okay, I can remove this one. And the last one, actually this one also is not needed because of the auto-discovery. When we do auto-discovery, we look for singly implemented interfaces, but only locally in this group, right? So when we load all the classes in the source folder, if there is an interface, and if this interface is found only once in the set of classes that are loaded, then the alias is created automatically. So thanks to this knowledge, you know now why we can remove that. And so basically, hey, it's resource without an S. Okay, it works again, right? So now you know why we have this default configuration in Symfony, and you know how. So if I do a diff with the file that was committed or that was downloaded from the default configuration, we have some comments, but you don't need the comments because you have my voice. So we have AutoWire true, auto-configure true, that's the same. We have app resource, there is a star. We forgot the star, it's okay, we don't need it. You can also exclude some files or, yeah, some files. So we exclude some directories and some files we don't need to configure a service, but basically that's the same. There is just one rule we did not create, which is this one. This rule overrides the previous one and says, okay, for the controller's subfolder, add the tag explicitly. So this is bypassing auto configuration. Why do we know, why did we add that? Okay, the command above says it. A controller doesn't have to extend abstract controller. You can create a naked class like that that doesn't extend or implement anything and have it register as a service, but if you want to register it as a service properly, you need to add the tag or to make it public. So that just, yeah, for people that want it to do their way. Okay, back to the origin. So,
Can I ask a question?
sure.
About the public controllers. So is there any plans to make them work without being public?
No.
So it's basically not. I mean, I understand why it's not possible, but there aren't no plans to.
Yeah, there's no plans. Yeah, a controller has to be public because we have to start with something. Yeah, so then they cannot. They could be made private by exposing one service locator, which would hold all the container and wire that. I'm not sure it would be worth it. So we didn't spend time on that. What's the difference between a public and a private service?
It can be requested with the get this controller, this container get.
Yeah. It's okay for everyone? So there is the container is an object. You can get this object in your application, in your class. And when you have this object, there's a get method on it. And you can get only public services. Right? So all services are private by default, which means you cannot get any service by default, which is nice. Because we don't want to get from the container. It's the bad kind of service locator. It's like tight coupling. We can discuss about that if you want. As you want. So, okay, back to the slides a few minutes, just to be sure I did not. So, we talked about that. That's exactly what we wrote. I just removed public false because that's the default now. It was not the case 2 years ago, so now we can remove that line, and actually we don't have it anymore. So, load everything in source with this resource, make everything private, do auto configuration, and do auto wiring for every classes. This is the notice we talked about, right? It's about AutoWiring works by name and not by type. So that's 1/3 of what I have there. But anyway. So now we can tweak the configuration to add some extra rules, because at some point it's going to be your application. So I told you about that. Defaults, this applies only to this very file. If you import another file, or if you create another service file, and if you want this file to define auto-configured, auto-wired, and so on services, you have to copy-paste that again and again and again and again. Right? That's on purpose, so that things are local. So binding. Binding is the answer to wiring string or parameters to classes. How do you bind? How do you inject an API key or the default local into one of your class? Using bindings is pretty common nowadays. So a binding is doing a mapping between a type and a name and a value. That's it. So this is saying in the defaults, it can be outside of defaults, but it doesn't really make sense outside of defaults. So this says whenever an argument is needed on a constructor, and whenever it's named default local with a string type, then this is the value you should provide, right? So this will wire things for us. Adding the type before string was not possible in Symfony at the beginning of Symfony 4, so it's kind of a new feature. But if you're using recent Symfony versions, it works, and you should always use it, of course, because it's more specific, right? So binding works for scalar values like parameters, this one. It works also for any service. So if you want to bind a different logger, you can define logger interface $logger or $mylogger and reference any service on the right side. It works also for services. Binding works for services. Okay? This one is instance of configuration. So it's pretty much the same as auto-configuration. You remember auto-configuration is about, oh, this extends abstract controller, so added this tag, right? This says the same, but it's local. So this says, in this file, if a service implements is an instance of this interface, then added the tag, right? So if you want to have local auto-configuration rules, this is the way. In case you need it, you know how to do it now. So we talked about that because we used that. This is about aliasing, and we already did that. So binding work also for arguments. I mean, you know, we use bindings in defaults, but you can use named arguments in explicit configuration if you need it, just in case just in case you need it. But okay, I'm not spending much time on that. So another thing is this one. There are several like exclamation mark after, we call that a YAML tag. It's not the same. It's a YAML thing. So this syntax says the first argument of the foo consumer class should be a list of services, an iterator of services. Should be a list of services who have the foo tag, right? So this will look in the container for all services that have the foo tag, and this will inject the collection of them into the service. Make sense? Yes? So if you want to get all the Symfony commands, you write that and you replace foo by console.command, and you will get the list of all the commands defined in your application whenever you need that. So this will generate an iterator which means something you can for each over, so you can for each on this argument. Maybe we can just do it very quickly so that you can see it running. We're going to do it with the console argument, the console command. So config. So I'm going to do something that doesn't make sense, but anyway. Console. Okay. Oops. Can anyone see the mistake I made? Sorry? Where? This one? Ah, okay. Yeah. This. Oh. No, that's for another reason. Okay, so tagged iterator is actually the new name in Symfony 4.4. Before, or actually in stable releases, it's like that, right? Which means the same. This one is deprecated, or will be deprecated in 4.4. I'll tell you why, just in a moment. So right now, if you see at the list of commands, it's a pretty strange object which is called a rewindable generator. But that's a technical implementation detail. What matters is that now you can for each and yeah, do that. And so we have all the comments there. Right? So we just collected the comments. Yes?
In this way of tagging, for example, is something like this, like a component class that actually collects all those services tagged with.
Okay. So the question is, when you have a collection of things like that, you get one object, which is the collection. There is another way to use a collection of services, which is to use them to add them through a method call to a service. Like the tweak path we saw at the beginning. We have several, we have add path 1, add path 2, 3, 4, 5, 6, okay? With a collection, we could ask Symfony to call add path for every step of the collection. So we cannot express that directly in YAML. So if you want to do that, you have to write a compiler pass. That's typically something a compiler pass should do. You cannot remove the compiler pass. It could be something one could express. Maybe one day someone will do a pull request because let's say this could be like that. Okay, tagged. This is the name of the tag. Or maybe it's tag. I don't remember. And we could have that's me creating this. It doesn't work. It doesn't exist. There is no implementation. But this could mean for every service in the collection call the add command on the greeter service. This could mean that, right? It doesn't exist yet.
For example, if I have an array of services and I'm passing them through the constructor, basically I can use that, right?
Yeah.
If I'm not using single method call for every new
Yeah.
service, right?
Absolutely. If you can provide the collection to the constructor, done. Then you can iterate in the constructor and call the add command right inside of it. Then it's your business. So, so this is providing us with a collection, okay? There is something else we might want, or there is another way we might want to access the list of commands. Which one? Do you have an idea? I mean, we added, I'm going, so this is the Symfony 4 way, 4.4 way of doing the same, right? We created it because there is something else we can put here, locator. So now we are asking Symfony to build a service locator out of the collection of services that have the console.command tag. Okay? So this means now we are going to get a service, a container interface, actually, that the interface that is going to be generated. So let's give it a try. I'm not 100% confident on this one, but let's. So container interface. I'm going to dump the comments. Okay. So it won't work. Maybe I didn't save the file. Tagged locator doesn't work. Ah, that's funny. I don't know why. It generates that. So it says rewindable generator. Okay, I'll have a look later so that we can continue. Okay, I'll have a look later. So we can inject, or we can ask Symfony to generate iterators or locators. This replaces many compiler passes that you might have written in the past to collect anything. So if you combine that with, like, okay, that's the next slide maybe. So if you do this kind of combination, this one is pretty powerful. This one, in a few lines, says, for every class defined in this application that implements this interface, add the tag. And then the next line, the gray one, says, provide all those services as a collection to this consumer, right? So it's pretty powerful. It will screen all the application, says, okay, I'm taking this one, this one, this one, this one, because they implement that, adding the tag. And then, okay, let's take all this collection of defined by the tag and generate an iterator or a locator out of it. Okay? Any question on that? It's okay? I'm going... so this is completely unrelated. This is about accessing to environment variables. right? So when you need, sorry, I'm going to the code. Okay, so I'm going to now pass it in a string. I'm going to reference a parameter here. Okay. Fine. Okay. I made a mistake in the YAML file. Okay, so you understood, I think, what I did. I created a parameter, greeting format, I give it a value, and now we are injecting the value there. We can define this using bindings, right? So I could also remove the definition and say bind greeting format to this. So I'm just using what I told you before. Okay, nice. Okay, so now we have a state where we inject a scalar value. What I want to do, so the next step for my slide is to reference an environment variable. So to reference one, we say env, and then the name of the environment variable, right? So if I do that, I can now open my .env file and define it. This way. Okay, now it's completely different, right? What happens is that at the runtime, we read the environment, right? Which means that if I change the value here, it's updated instantly. By instantly, I mean before changing the YAML file means recompiling the container, which is a slow process. Now it's instant. There is no recompilation. Okay? So that's the benefit environment variable, allowing to reconfigure dynamically an application. So this is not what you will use environment variable for, I mean the greeting. But if it's the database host, this is the kind of thing you want to switch very fast without recompiling the application, because you want your application to recover from a failure of the database very, very fast, right? So, environment variables, you can define them using environment variables of the operating system, but you can also put the values in files, and there is something which are called environment variable processors. A processor allows actually processing the value of an environment variable. So let me show you, it will be more explicit like that. I'm going to say greeting format file here because I'm going to put the name of a file here. And the name of the file, I'm going to say, okay, it's kernel dot project dir slash greeting, like that. So this is using a reference to a parameter, yes, and then the name of a file. I'm going to open that and say here in French, right? And now I need to reference that. So if I do that, okay, it doesn't, too few arguments. That's strange. Oh yes, I know why. So I'm going to dump. Let's not care about the error for now. So this is, as you can see, this is the value that is provided to the constructor, which is the value in the .env file, which is the value of the environment variable, right? So now we need to process it. What does processing means? It means transforming that into the actual content of the file. So how do we do that? The first one I could do is like resolve. Resolve means replace parameters. So refresh, resolved, right? You can see now we have the full path and not a reference to the parameter. Now we say we miss another processing step, which is, hey, open that file and give me the content. That would be useful, right? So we do that using file. And now it works. So that's environment variable processing, right? So you can, there are many processors now. We added more recently. There is one to JSON decode the content of the file, which means that if my file is JSON encoded, I can do that and JSON decode the content. Now maybe the JSON decoded content is an array and I need a specific key in the array. So maybe I can, so then I can do that. At some point you're going to say me it's cryptic, you'll be right, which means at some point you might need another way to reference, you might need a service actually, at some point. But still, it's pretty powerful, so if we do that, it says, take the greeting format file environment variable, replace parameters by their value, open the file, JSON decode it, and get the FR key from the resulting array, right? There are more. We can continue the list of processing steps. So if I do that, it still works. But now the processing step is a bit different. Okay? So, in case you need it, you know how to do that. The title gives the most common use case for that, which is secrets. So putting secrets in real environment variables is considered not the best practice, because in real environment variables, they can leak. If there is a misconfigured server, like a server that has a PHP info page, you know, that happens. You can Google for that kind of pages and you'll find many of them. And these pages, they list the environment variables. So if there is a secret token API key there, done, leaked. So there is a way to efficiently guard against that, which is to put the secret in the file and then to read the file. Done. Okay? Okay, so this is what we saw together. It's just a summary for what. Okay, some notes of that. That's slides. I'm going about that. So what about performances of auto wiring, auto configuration? This is the answer. You know about it. Everything is compiled, so nothing happens at runtime. So the core one, there are two things that make PHP a PHP application fast, and only two things. One is laziness. Do nothing if you don't need to. And that happens at every stage in PHP, like auto-loading, the core mechanism that loads our code, is lazy. We don't load everything. We just need load the classes. So that's the same for services. They are created only when you actually need them, right? The second performance, the second way to be performant in a PHP application is caching. That's it. There are two ways, two core root foundation. Lazy, do nothing, cache, don't do it twice. So laziness, the iterators, the tagged iterator, you remember, it's a rewindable, something like that. So it's lazy. If you don't iterate over the iterator, you don't create the services. And if you stop in the middle of the iteration, you will not instantiate the last services in the list. So that's another way to have laziness. It's the same for service locators. So a service locator is something where you can get a key, get a service, right? But the service is created only if you demand it. So that's another, so that's service factories. Okay, this one is quite old now, but this is the performance profile of an application before and after the pull requests that introduced splitting service factories in separate files. If you remember, I showed you before that the container is dumped either in methods or in specific files, right? So before that, it was dumped in one gigantic single class with many methods, and many of them were not used, right? So before, the big container was like it's runtime data. It's like 130 milliseconds to load, and after the change, which means don't load things that I don't need, it's like much faster. There is a trick on this screen, which is that this is for a console application. So a console application doesn't have OP cache. OP cache is the thing that prevents PHP from compiling the same file again. But since consoles don't have shared memory, they cannot cache the compilation step anywhere. So PHP has to parse the big file all the time, and it's slow. PHP 7 is slow at compiling files, right? So, of course, in a web app, the difference is not big. It's very small. Okay, service locator, I told you about that. So, what's on this? Yeah, okay, I don't care. Or maybe not. What about performances? Oh, yes, okay. That's the next step in performance. So right now in PHP, we all run the Symfony application in short-lived requests. Like a request comes in, we start the script, we run the script, we kill PHP, and we start again for every single request, right? And at the beginning, when the request starts, we have to load the container, load the services. For every single request, we have to do that. This has some overhead, and there are some people that run Symfony or maybe other kind of application as long-lived processes, which means you boot one process, and the same process, the same Symfony kernel is used several times in the loop, right? So you need a special web front end to do that, web server to do that, but then you are able to reuse the same kernel several times in the loop. This is quite kind of experimental. I'm just sharing that with you so that you can imagine that the limit is not there. There are people that are trying to go further. So a long-lived kernel is a kernel that should not leak from the previous request to the next one. Right? The very important benefit of short-lived requests, the kind of request we all do, is that one request cannot affect the next request because the process and the memory is killed, is emptied before. For long-lived kernels, that's not the case anymore. We need more safeguards to be able to actually reuse the kernel. So one solution to that is to write stateless services. So a stateless service is a service that you cannot reconfigure at runtime. So what's reconfiguring? Let's say you have a block layout system. If there is a set background color on the block layout, if the previous request said set background color red, you don't want the next request to be red too, to have the red background too. You would want it to have the default background color, right? So I'm using the color example, but basically stateless means don't mutate a service or, yeah, don't do it. So services should be stateless. That's a core design principle of services. Having a setter on the service might be a design issue because a setter allows changing, reconfiguring a service at runtime, which should not happen because it breaks this use case at least. It's okay? If it's not, tell me because I'm using like, I'm trying to explain it, but maybe it's not that easy. So then there are services that are not stateless by design. One of them is the profiler. The Symfony profiler, the toolbar, is a service, and what this service does is that it collects everything that happens from the beginning of the request up to the end of the request. So by design, it is not stateless. It collects, it buffers things. So that's one example, and there are several of them in Symfony, but maybe in your application too. So what we need is resetable services, right? So this kind of service, they expose a method, let's call it reset, and there is a tag, and this tag says, okay, for this service, the next time you're going to use the kernel, before actually reusing the kernel, call the reset method on the service. So for the profiler, it means first time, the profiler collects. Then the kernel is rebooted. And when it reboots, it says, oh, I'm calling reset on the profiler. So we empty the profiler, and we're ready for next request. Make sense? So that's resetable services. You can use that tag yourself. Actually, there is an interface in the service contract, which is called no, I don't remember. It's reset interface. I think it's reset interface. So Symfony contract service reset interface. If you implement this interface, it means you're going to implement a method which is named reset, and you will get auto configuration. And you know that auto configuration will provide you the kernel.reset tag. So actually, you will have nothing to do to have a resetable service. Just implement the interface, and done. It will be reset for you in a loop. Yes? Oh, okay. That's the third. This is about challenges for long-lived services. So this is the most difficult one. It's resilient services. So community work pending, it's quite, I think this is not solved at all. So what's a resilient service? Do you have an example? It's the database connection. Because the database connection right now, it cannot fail during a request. If you manage to create the connection at the beginning of the request, when you need the database, it's going to be available up to the end of the request, because the request is short, and the database connection doesn't fail in that short amount of time, right? So with the way we do requests right now, we create database connection for every single request that needs one. With long-lived requests, we have one service, which is the database connection service. We have one connection, and if this kernel is used for 1 hour, then we have one single connection to the database, which is reused for 1 hour, which is nice. It saves us with the connection setup, round trips, and so on. But what happens? During 1 hour, I'm sure there can be some network or database reboot or failure or something like that. So that's what I call resilient services. It's making the database service able to reconnect automatically when the connection needs to, right? And I think this is not completely covered for all kind of connection and so on. Okay, that's just for history. Okay, I'm going to move on this one. So these are specific parameters that enable behaviors that are the default in Symfony 4. So just telling you, how much time do we have? Okay, so I have another. So I have a list of things I can tell you about. I don't know how you want to spend these 20 last minutes. I can just throw them at you so that you can, as you want, or we can go deeper into some specific topics if you want to do code. So I'm going to start, and when you're fed up, you say, okay. Or when you have question, actually. Maybe that's a better way. So, so you know, we saw that first point. Injecting services as argument into actions, easy. We did it. Service subscriber interface. So this is an interface that allows the service to say, I need a container that should contain only this and this service. I can show you one, because we have one, actually. The abstract controller, absolutely. So the controller here yeah. Gets, yeah. Subscribed services should be better. So I'm calling a method from the abstract controller, okay? And so there is a method which is called get subscribed services, which is the only method that you need to implement with the service subscriber interface. That's a lot of words. So the key is the name of the service you need in this specific class, and the value is the type of the service you need in this class, right? This is provided by abstract controller, but you can add your own. So if you want to, you can add to that list. You can make the method return more things than what is there. So this says, I'm going to need a container that should contain a router, which should be an instance of a router interface, and so on. So this is asking for all the services that the abstract controller needs. Why is this useful? When is this useful? When implementing service subscriber interface is useful. So this makes the code able to have that. I'm going to say this container get router. And this is the router. Okay. This is the root. I cannot scroll up. Okay. This is showing me the router. So because the router is listed there, this is defined, right? Now we can also maybe ask the greeter because it's a service, right? But actually, this says, even though it exists in the apps container, the container inside the web, inside our controller, is a smaller locator that only knows about blah, blah, blah. Right? So it's not the container, it's a very small container whose definition is given by this list. So it allows doing explicit configuration of your dependencies. It's pretty much the same as listing constructor arguments with their types, right? Except that it's not using constructor arguments, it's using an array. So the benefit is laziness. You remember that slide? I listed service locator on the laziness slide. If you need the router, or if you need a service to be very lazy, if you need the service to be created only when you actually need it, maybe nested deep inside some conditions, then you might want to use a service locator. That's one use case, right? So in Symfony, we love service locators, and you will find many blog posts saying service locators are an anti-pattern, right? Both are true. So a global service locator is wrong, like using the container for fetching any service is wrong because it hides the dependencies of your class. But since we made the dependencies of our class explicit with this array, we fixed the problem and we kept the benefit of the service locator. Okay. Okay. This is, okay, PHP configuration. I'm going just to tell you this about, so we used YAML as a configuration format, right? You can use XML too. And there is a PHP, there's a way to do the same in PHP. So it's pretty much experimental. There are people that are using only that because they love it. It plays nice with PHP Storm and so on. But, okay, it's not mainstream yet. Okay, I'm not going to give you much more on that. So, at required. Who knows about this one? Hmm? No, that's not for this one. So, it's about AutoWiring. AutoWiring works by looking at all the arguments of the constructor, right? And saying, okay, I need to pass a greeter to this controller, right? There are some services that need a dependency through a setter, like set logger, right? So set logger, the AutoWiring logic will not look at setters because it doesn't know about it, right? So the AutoWiring will work only for constructor arguments. If your class has a setter, and if you want to have AutoWiring call it, you can ask it to do so by adding this annotation. So if you add a dog block on top of a method, and if this dog block says at required, it means to the AutoWiring logic, do your job on this method too, and call it. Right? So if you add at required on this method, which is called setLogger, then the method will be called when the service is created. The kernel which implements compiler pass interface, okay, if you want, in Symfony 4, in Symfony Flex, we changed the directory layout, as you might know, and we removed the app bundle. The app bundle, or a bundle, is useful because it allows registering compiler passes pretty much easily. But this is gone now. You can still make it. You can still do it, but you have to look at the documentation. But if you need a compiler pass in your application, you can implement it inside your kernel. So the kernel class in the application, this one, right? It defines the how configuration be loaded. But if you now implement compiler pass interface from the correct namespace, you can implement right into this class a compiler pass. And compiler pass is about a method which is called process, which takes a container builder and does things. Okay? So if we do that, this will be called automatically during the compilation of the Symfony apps. So in case you need it, you have the hint. Any question? Or anything you want me to showcase, or because I have the other list? Oh yes, there is something very important. I should have started with that. So, okay. Does it work? Does the application? So I'm sorry, I'm switching a lot. Not yet. Back to this. Okay, this works. This doesn't because of that. Okay. Symfony comes packed with features, right? There's a router, there is a caching layer, there is doctrine, when you enable the doctrine bundle, etc., etc., etc. How do you identify them? How do you know about the features that Symfony provides? Did you think about this question? What's the menu of a Symfony application? How do you do? So you have an application and you say, okay, services. There might be a service for solving this thing I want to do, right? And there are many services. So maybe you look at the documentation saying, I want to do that. And there is a page that tells me there is a service that is named TWIG. What's that? Oh, it's useful, a template engine, right? So that's the menu of the application, right? Twig is part of the menu of the application. So how do you look at the menu of a Symfony application? That's a good start. But this is the skeleton. And if you look actually there, so let me take this one. This one is auto comment make functional test. It's a maker command. I'm not sure it's part of the menu of what you want to build in your application. I'm not sure you want to do something useful with this service, right? So some services there are what I would call useful services for your application. And some, maybe most services listed there are like services you don't care about because they are just internal things. You might want to alter if you do some advanced things in this area, but maybe not. So the real menu is a pretty new application. It's called debug AutoWiring. Correct. So debug AutoWiring is the most important command for discovering what a Symfony application is capable of. So if you look at that, it lists the types and provides a small description on top. For all types, you can easily auto-wire. So this says there is something you can type in for, which is called PSR log logger interface. If you type in for that, you will get the monolog.logger service. And you will get an instance, okay, that describes a logger instance. The description is not very useful. But basically, that's the idea. The description should be improved. We have many descriptions which should be improved. But that's another one. If you want to read annotations on your classes, if you want to, there is an interface for that, and you can type in for it, and you will get a reader. Then it's up to you to do something with the reader, right? So, yeah, not all services are useful for your use case, but they are all useful services for some apps. And this is a subset of the other services, right? So how do we identify the useful services among all the available services? We list only AutoWiring aliases. And that's it. The definition of a useful service is an AutoWiring alias. So the greeter interface should be here. It's there. As you can see, we have the greeter interface. It's part of the useful services. But the app greeter, which is also a service, is not listed. It's not an AutoWiring alias. It's a service, right? And it's nice. It encourages you to type it against the interface, the abstraction, and not the actual implementation. You see there's a nice feedback loop there. So if you want to do caching, there is the cache item pool interface. You just type it and you get a cache pool, etc., etc. Right? So the next step is named AutoWiring aliases. This is critical. I mean, for the future of Symfony apps, I think this is going to be more and more mainstream and a more common way to ship features to applications. So what's a named AutoWiring alias? It's an AutoWiring alias that matches by type and by the name of the argument. So what happens when we have, let's use the cache pool example because I can showcase it very easily. So you want to cache objects, right? And you want one cache pool for the result of some API, and you want another cache pool for the metadata of some images, right? So that's two separate caches. So that might be two separate services, like cache pools, and they both implement the cache interface. So if you type in for cache interface, which service should be provided? The one for the API result or the one for the image metadata? None, right? Or it depends. So how do we make things more explicit so that Symfony knows about that and so that the readers of your app know better about that? By naming your arguments correctly. So okay, maybe this is a bit abstract, that's the concept. So let's use that. You can also do binding, absolutely. But binding is local, so it doesn't define a global convention. And binding works only for your own services. Now, that's why I'm starting explaining you that with the debug AutoWiring command. It's about the menu. What's the menu of the application? And for your own application, you can use bindings. But what if a bundle wants to provide, I have an example. There is a fly system bundle. The fly system bundle, so fly system is a file system abstraction, and you can define several stores for user uploads, user picture profiles. One goes to S3, the other one goes to Redis, right? So it's storage. So there is a fly system bundle. In some configuration, you say, okay, I define two storages. One is called user profile pictures. The other one is called something else, right? So you have two storages. This is defined in the bundle configuration, so it's not related to binding. You will not bind those services that are defined by the bundle. So the job of the bundle is to provide the aliases. So config, package, cache, I think there is one. Okay. So let's forget about that. So this is an API cache. And I don't know, another ID. No, I don't have. Okay, I don't care. That's two sets of cache pools, right? They store different kind of objects in different parts of the application. So now we just define two pools. It doesn't change anything here because we don't use them. But if I run the command again, I have this. I have this, and this says there is one AutoWiring alias for the interface, which goes to cache.app. But there are two more that add the name of the argument after. And if you name your argument according to the name there, you will get not the default one, but a specific one. This is very powerful, right? We just define some configuration, and now we can just go back to code and say, now I'm in my greeter. My greeter needs a cache interface object, but only for API. So nice, I have a nice name for it. This one, and done. We will get the API cache. Right? Make sense? So this is what I call named AutoWiring aliases, and it's only the beginning, I hope, because I think it solves many interesting problems. Okay, so what time is it? So this is the list of things that I may not have talked about. So named AutoWiring aliases we just did. Container inline factories we don't care. Compiler passes. Okay, look at the doc if you need the compiler passes, because this is old knowledge. I mean, Symfony 2.0 has documentation for compiler passes. So explicit configuration, we did it. Debug AutoWiring, we just did. Tag locator, service locator, we did too. So the locator or the tagged, sorry. Okay, you can also define iterators explicitly. If you define an argument like that, right? So arguments, so it's an except. But if you do that, you are creating an iterator over two services. Okay, and I think I'm going to, let's say what's there.
Sorry, what about the line 13?
This one.
Yeah.
Hey. So that's the greeter. So you see the ID. This is, okay. This is, for now, I'm going to call it set logger. Okay. This is pretty common. This is a setter, right? Set logger, set the logger. If you want to create an immutable service, I told you about immutable services before. There is a trick, or there is not a trick. There is a pattern. When we have set logger, we just made our service immutable. It's not stateless anymore, right? We can change the logger at runtime. So how do we fix that without removing the setter? We turn it into a wither. A wither is, that's not enough. So a wither is about that. Right? If you do that, if you do the set this way, you don't mutate the service anymore because a new object is returned, a clone. Yes? So we just made the service immutable because technically we cannot mutate this. But we have now something that the container should know about. And this thing is that the container, let's say that we delegate to the container creating this greeter service, like we did since the beginning, right? So we should tell the container should reuse the return value of the wither when calling it, right? So let me do something here. Greeter. Okay, this is creating the object. This is the kind of code that is dumped inside the container, right? So then the previous was like, with a setter, it's pretty easy. Let's imagine the container generates this kind of code. Easy. I think you get how it works. Now let's make it work with a wither. If I do that, I did not change the greeter object. What I need to do is that. And now the greeter variable holds the configured service, right? So that's the line. The line is saying we made the container able to generate this kind of line instead of only the setter version, the variant, right? So that or that. How does it work? Right now it wouldn't work. And so it can work using explicit configuration. There's a way to doing YAML. There's a way to say, hey, this is a wither, right? There is another way when we use auto configuration, which is to use this. If you add this annotation, you are telling the outside world that this returns a clone of the current instance. This is what this means since always. If you look at all classes that return static, they do that. So the container will look at for this annotation and will figure out by itself. So you made your code more explicit, clearer, and it works better. So that's the wither. Answering your question. And I think, yeah, time is over. Okay, thank you.